All right, here we go. Starting over again. We didn't have product rule, quotient rule, chain rule for integrals. We need something to allow us to solve more indefinite integrals. We have something called the UDU problem. There are some breakdowns with UDUs. What I mean by that is when we got done with when we got done with derivatives, you could pretty much take the derivative of any function I gave you. Some of them were really ugly, but you could do it. The same is not true about integrals. These problems that we're going to do are very premeditated, for lack of a better word. When we get done with UDUs, you can't go out into the world and take the integral of any single function. It's going to take a little bit of finagling in order for that to happen. Okay? So, the best way to do this is to just dive into it and look at examples. What's going to bother a number of you is you're going to make some mistakes. You're going to have to make a choice when you do a UDU problem. And a lot of times your choice is going to be bad. That's okay. I'm going to show you how to recognize when you've made a mistake and fix it. And in one problem, you may make 2 or 3 mistakes. But again, I'll give you the tools in order to recognize where your mistake is. Eventually, you'll choose wisely. Anybody know what movie that's from? Which one?
One in Egypt.
That would be the third one. Yeah, Indiana Jones and the oh look, I found the Holy Grail, whatever that one's called. Yeah. What's that?
Which is the one with the big ball chases him?
Oh, that's the first one. That's Raiders of the Lost Ark. Yeah, where he steals the gold thing and then the.
Oh yeah.
Yeah, that's a good one too. They're all good. There's a ride
Oh, sorry, yes.
where you have to run away from a ball.
There's
That'd be Disney.
It's like a show. There's a new ride at Disney.
Yeah, wait,
Yeah.
It might be a Disney.
That would be an awesome ride to just watch people try to run.
There's like a Disney thing.
At Disney World, they have like a show.
It's like a thing that like this actor like he plays Indiana Jones and he runs away from a ball.
Yeah.
Okay,
And then it like takes
yeah,
him
but
away.
so you're not actually in the
No,
ride.
you would go watch the
There is a
show.
ride.
It's like a ride. You're a ride and then it's like on the side and you just like watch. It's like the race away from
I don't know.
All right, so here's our most basic example. This is called a UDU problem because we're going to make a simple substitution. We're going to create something that we call U and use that to solve the problem. Now notice, this is a chain rule. I've got a function within a function. Yes, you could rewrite that as 8x plus 5 to the 1/2 power, but it's still not going to help you because integrals don't allow us to be, or we're not allowed to do integrals using a chain rule. So how do I do it? Well, you have to make a choice. And that choice is the following. You're going to choose some part of that function to represent as u. I'll do the first one. I'm going to choose u to be 8x plus 5. You'll see why in a second. Every one of these UDU problems involves a sidebar. Okay, so I have to do a little bit of work over here. First of all, I'm going to take the derivative of both sides. Derivative of u is 1 with respect to u, so that gives me a du on that side. And then the derivative of the right-hand side is 8 dx. Everybody good there? I know it's been a while, but you'll catch up to me. From this point forward, there are a couple different approaches. I'm only going to show you one approach. And it might be different than the way, say, Helene or Bryony or Harder or Hernandez teaches it, but I think, after my experience, this is the best way to do it. I'm going to solve for dx. So dx is equal to 1/8 du. Everybody else saw that, right? Or did I just have a seizure? They did flash, right?
Yeah.
Okay, my goodness. Woo. Okay, so step 1, pick a value for u. And as the problems get nastier, you'll see how many different things you can choose for u. Step 2, take the derivative of both sides over on the sidebar. Step 3, solve for dx. Now I do a substitution. I want to turn the original problem into a function or into an integral involving u's. So this becomes the integral of the square root. Well, I know what 8x plus 5 is. That's u. How do I know that? Because I picked it. And I know what dx is. What's dx? 1/8 du. Okay, let me stop there for a second to make sure everybody's with me. Yes? Doesn't seem that difficult, right? Okay, that's why we're going to take baby steps here. All right, 1/8. Remember, you can move the constant out in front. That's u to the 1/2 du. And now we do some calculus. Now notice I haven't done any well, I did do some calculus. I took a derivative. I lied. I'm just going to be quiet and keep working. Adrian, let's put you on the spot. What's the antiderivative of u to the 1/2?
Isn't it?
I know it's been a while. We forgive you. And they're just happy I didn't call on them.
To you?
To me?
No. What did I do there? You said to you, I said to me. Is it not to you?
Not to you. Assistance, anyone? Katie?
2/3 u to the 3/2.
Good. Raise the exponent by 1, 3/2, multiply by the reciprocal. 1/8. As my grandfather would say, 2/3. As you get better at UDU problems, you're going to cut some of these steps out. Like, for instance, you're all fairly bright. You can multiply 2/3 times 1/8 right away. But not my final answer. Why is that not my final answer? Because that's in terms of u. That's not what the problem started with. The problem started with x's. So, last step, do a little bitty substitution over here. Ooh, that color's too hard to see. That one's better. 1/12, 8x plus 5, raised to the 3/2, plus c. Pretty good.
Do you have to like simplify that? or
No,
is
no,
that-
no, no, no. I don't care about simplifying right
Okay.
now. Just leave it like that.
Perfect.
No, I don't. You mean like, should I do it as the square root of 8x plus 5 raised to the 3rd power? And all
Or
that
just,
other.
like, or like just go through.
No, just leave it there.
everything.
All I
Okay.
care about is right now is learning the UDU process. Any other questions before we move on? Pick a value for u. Take the derivative. Solve for dx. Substitute. Okay, so since this is our first one, let's go through that again. 1, pick a value for u. 2, take the derivative. 3, solve for dx. 4, substitution. 5, do some calculus. 6, sub back in. Do you want those again?
So how come we can move the 1/8 to the front again?
Because you can take, you don't have to have the constant inside the integral. You can just do the integral and then multiply it by the number at the end. Are we good? All right, let's ramp it up. Let's go with blue. We'll do this. Now, could this be done a different way? For sure. I could take 8x to the 5th minus 7 and multiply it by itself 9 times, and then multiply everything by x to the 4th. But what kind of psychopath would do something like that? Not this guy. So, we need to pick a u. Matthew, you're up. What would you like u to be? No, wait, stop. Never mind, not you. Smitty, what would you like for u? Should I give you some options?
Yes.
Turn it into multiple choice?
Yes.
Okay, so you could choose u to be that entire mess. 8x to the 5th minus 7 to the 9th power times x to the 4th. That's never going to be the case, but if you want to choose it, it's America. 8x to the 5th minus 7 could be u. X to the 4th could be u. 8x to the 5th minus 7 to the 9th power could be u. 8x to the 5th could be u. X to the 5th could be u. X could be u. Now, the non-smart choices would be the whole thing and just x. Those are redonkulous. We're never going to do that. What do you want to give a shot to?
8x to the 5th minus 7 to the 9th.
Great. Okay. Now, before you all start writing like mad people, she's wrong. So that's good, though. You played into this perfectly. Now, I'm going to show you why she's wrong, because with U-to-U problems, this is the most challenging part. How do I know when I screwed up? Because I'm not going to be sitting next to you every time to say, no, 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 that's wrong, do it again. So I'm going to start this problem following the same procedure I used on the previous one, and then we'll get to a point where you realize where the mistake is. Okay, so 1, we picked a value for u. Number 2, take the derivative. Okay. Yeah, solve for dx. (360x to the 4th times 8x to the 5th minus 7 to the 8th power times du). Okay, we're doing okay so far. There's no big deal here. Now we substitute. Okay. Not pink. Let's go with orange. All right. This we chose as u. So that's going to be u. Then I've got an x to the 4th, because I don't have anything to sub in for x to the 4th. Then I put in dx. Well, here's all of dx. 1 over 360x to the 4th times 8x to the 5th minus 7 all raised to the 8th power dx. Okay? For those of you that are observant, you'll notice that this x to the 4th cancels with that x to the 4th. The 1 over 360 is a constant. That can be moved out in front. So I end up with the following. Whoops, I made a mistake earlier. This should be du. There we go. Okay. So now I stop. Now, that's bad. How do I know it's bad? When you get done simplifying and canceling things, if you have x's and u's, you made a mistake. And again, one of the first things I said is you're not going to be happy about this, because look at all that work I did before I get to a point where I realize there's a mistake. So what do? I hate to admit it, but you erase. And do it again. All right, Em, chance for redemption. What would you like next, Lassie?
8x to the 5th minus 7.
Do you want to do this? Yes?
Yes.
She chose wisely. Okay. Now, one of the tricks that you'll learn is, notice I've got that x to the 4th just kind of sitting there by itself. Well, what happens when you take the derivative of 8x to the 5th? It reduces the power by 1. Ooh, good sign that that might cancel. So one rule of thumb you might want to follow is that you try to choose the higher degree part of the problem. Same procedure. du is equal to 40x to the 4th dx. Ooh, looking good so far. Substitution. U to the 9th. I got this x to the 4th I can't do anything with yet. 1 over 40th x to the 4th du. Initially, I would say that's bad because I have x's and u's, but again, from what we saw before, wha-bam, wha-bam. Ooh. Good to go. The integral of u to the 9th. Put the 1/40th out in front. du. Now here's the nice thing about u du problems. Once you pick your u, you do all the other 6 steps. The derivatives are usually pretty easy. Usually. As is the case here. Adrian, chance for redemption. What's the antiderivative of u to the 9th?
U to the 9th. So you add 1.
Yeah.
And then take the reciprocal, right?
Yeah.
So it's 1/10 u.
Wonderful. 1/400th u to the 10th plus c. I multiplied the 40 times.
Yeah. I didn't see that right.
Math guy.
Gotcha.
Okay. Step 6, substitution. Next. It's so weird. The green looks bad up here, but it looks awesome over there. Awesome, gunky, awesome, gunky, gunky, gunky.
I think it looks hard anyway.
You don't think it looks good? I think it looks pretty good over there, doesn't it? Kind of
But I
close.
think it like it's.
All right, I won't use the green anymore then. God.
Oh, maybe not on the gray.
Molly, question.
Wait, so for du, where does that go like in the next step? Like, where
Well, remember when you take the antiderivative, that's just there to tell you, hey, my variable is u.
Oh,
Once you take the antiderivative, you don't need to tell people that anymore.
okay.
Okay.
How did 140 turn into 1 over 100?
Adrian,
Yeah.
how did 1/40th turn into 1 over 400? What kind of math voodoo did you use?
We took the antiderivative, which then we multiplied with 1 over 40.
Oh,
get
it
1
was
over
140th u to the 9th, and that whole thing is the antiderivative. Oh.
Okay? We good? Let's see what's next. Oh. Wait a second. You said there's no such thing as quotient rules. There's not. Atlas, your turn. What would you like to choose for you? Would you also like a multiple choice question?
Yeah.
5x to the 4th plus 6x. X to the 5th plus 3x squared plus 5. X to the 5th plus 3x squared plus 5 to the 3rd power. The whole thing, or just x?
Can I try 5x to the 4th plus 6x?
Certainly. It's wrong, but you want to try it anyways?
Um,
Now, remember what I said on the last problem. When in doubt, take the higher degree for the u value.
So x to the 5th plus 3x squared plus 5.
That's it. No cubed on that.
Yeah.
Good. Oh, watch that floor slippery. X to the 5th plus 3x squared plus 5. Okay, you do the rest. Go. Come on now. I did the hard part. Well, Atlas did the hard part for you.
But I haven't understood that part.
Pick a value for u. Take the derivative. Solve for dx. Substitute. Do calculus. Substitute again. Back in for x. Man, we are having fun now.
That's like one-sided. It's in
The desk pet's out there, ready to rock.
I was laughing during notes.
Remember that first day out in second semester when you lost your soul to the rabbits with no eyes?
Yeah.
Why did I choose them both? Why are they holding hands? Little like, what is it, the Shining Twins?
That's what I was actually thinking.
Is that supposed to be like
They're just scary just
Okay,
demon
my
rabbits.
rabbits for like getting through the class.
Yeah, I don't know why.
I really thought it was.
Like, is there 2 dx's with that?
Where?
Actually, you did.
I'm going to take the regular derivative and then you stick it dx on the end.
Right now. No, I'm just excited that I understand it.
Hey, and that's like really like have you. So
No, they are not having fun, but they understand.
What's dx equal?
Wait, hang on. I'm like.
Wait, give me a minute.
Okay.
I was distracted by the.
So the dust boat even
Over.
Yeah, sorry.
They speak really cool, so maybe let's start there. I love them.
You can't spread over there.
Oh, and it cancels out. That is very nice. I love when it does that. Make it negative. I know.
You are so smart. This is why I keep you around.
It's backward today.
And then don't you plug it back in?
Well, I know you for.
Plug into yes.
But I still hang out with you because I'll be
Oh,
switch into my math class.
God, it sounds like a
Wait, can you put your palm on here? Is it not? No.
Wait, why is there more?
Took me a while to get used to it.
No, I can't. I still have to see
Oh,
Oh wait, it does. I can't see what you're saying. But I'm like stumped.
What was that? Was there anyone in there? So they got those little
Somehow you hold the bucket up, you full, they run 4 elements. A fire brigade going.
Oh, I forgot to fix it. Yeah, and then I put fire. I don't get it.
I'm not gonna simplify this. You put it where you was.
Oh, you put my. Yeah, thank you. Oh, I did the same thing, so I hope you also did it. We go ahead
I just looked at the next problem. I had to find every single trig function. It says, like I learned every couple months, and then I just immediately forget
I
it.
learned some for the final.
Exactly. I learned it for the final, I did the final, and then I immediately forgot.
I meant to learn for the final. I mean, I feel like for the AC class, it's really not.
You finished the problem.
Yeah.
What's a pirate's favorite letter?
R.
No, C.
Oh.
wait, what?
Mine? Oh, no, that is what I got.
You be quiet over there.
That's what I got. I just didn't.
All right. So Luke is going to explain what he did, because he's a smart feller. What happened?
So you take the derivative of u and then you get du is equal to 5x to the 4th plus 6x times dx. Then you divide to get dx as du over 5x to the 4th plus 6. And then you plug that in for dx. And you substitute x to the thing plus 3x squared plus 5. That's equal to u cubed. And you plug everything in, and the 5x plus 4 plus 5x to the 4th plus 6 cancels with the other 5x to the 4th plus 6. And then you just take the antiderivative, which is negative 1/2 e to the negative second plus c, and you substitute that.
Because remember, you raise it by 1. -3 plus 1 is -2. Well done. Let's give it up for Luke. Excellent. Now, what's going to happen as you get better at this, you'll be able to cut out some of the steps. Like, for instance, you might be able to eliminate this step. But I would not suggest rushing it. If you need that step in there, put it in there. Okay, so you can see where everything happens. Common mistakes that people make. The first one happens over here, algebra. When they solve for dx, you put everything in the bottom. The du doesn't go on the bottom. It stays on the top or even behind it, but it doesn't go on the bottom. Second mistake is as soon as people see a scenario like this, they say, well, I'm done. I chose poorly. I've got x's and u's. I did something wrong. Remember, you have to sub in for dx also. Everything else is good to go. Don't forget to sub back in at the end so that everything's in terms of x. Questions? We do one more? No?
We did this one, so we can do another one. Depends what the other one is.
Wow.
Oh, it is.
U is 12x.
Easy peasy. Go ahead. I'm not going to tell you what u is. You try it.
Right? It wouldn't because so instead of 12x, it'd just be 12x, right?
Okay.
That's what U is.
That would make sense.
Life wouldn't be complete without a little bit of trick.
About
Are you guys going with 12x? I'm going with 12x. Let's see what happens.
Well, this is scenario we have to restart.
let's do 12
I'm not even. We're safe in case scenario. We do a lot of work.
Cosine.
This scenario we once worked and then it was all wrong. We have to do it all again. What's different? Hopefully not.
I didn't care what this
I think this is right.
Yes, because if it was the cosine of 12 times x,
Yeah.
the answer would just be
Yeah.
cosine of 12.
So then du.
That would be sine. That would turn into sine. Not negative sine, just regular sine.
Yeah. No, we're done.
Sign you.
Is that what you got? Wait, I'll note it again.
Yeah.
Okay, yeah, sorry. Sorry.
Wait, I have so I have, where does the D go?
Oh, that's what causes it to do antiderivatives stuff.
That's just saying you're taking the antidote. Oh, so she's.
I think it's just
Yeah.
She's fake, she's kind of flaky.
So that's 12 sine u
Yeah.
plus c and then plus c.
No, but it's like-
C. Okay. I always think it's c. That's okay.
What's your
I'm just
final
sorry.
answer?
1/12 sine 12x plus c.
I love this. When I do things right, that's actually so cool. Greta, you don't understand, like I actually never do things right. So this is like actually
Does this look like a factory
No,
toy?
I love it.
It does.
I'm so scared.
I see it.
It's so
Like a
great.
little industrial.
It does, actually, yeah.
Like an industrial.
An industrial. Why are my notes so pretty?
No, we have to think that if
Those characters.
I love it.
Everything's so right. Everything's so right. I was gonna dye my hair purple this week, and then I found out I'm switching it next week. So I'm
So
gonna
wait till after class.
No, but all the dance classes have some first.
Yeah.
What were you doing? Yeah. How bad is it?
Yeah, we've done it. It's honestly not that bad. I was thinking about it. She's like, don't come down there.
Why did she just put me in there?
But that's what she
I
recommends.
had like Schmidt and the younger demands.
Oh,
I don't really know what it is.
well, I did it.
Bigger purple, she's bigger than wrong. I just really hate them.
I was like, okay.
I got this one right.
I'm sorry, what?
We did that.
I don't know. Let's wait and see what Emily gets.
Okay, show me.
She gets first color.
No, we did it.
Oh, look, same. So you're either both right or both wrong. All right, Emily, tell us what you did.
Can you put the bunnies on?
Yo. Sorry, go ahead.
And then isolated dx. And then I put in u for 12x into the original. And then I replaced dx with 1/2 du and then took out the 1/12. And then found the antiderivative and then
Perfect. Let's give it up for Emily. All right, couple things. I know it's been a while, but we've got a basic integral here, an indefinite integral. This one happens to be in terms of u. How do you know that? Because I've got this du there. That differential is what it's called, tells you that the variable there is u. As soon as you take the antiderivative, in other words, you do this mathematical operation, this du goes away. It's no longer needed. Okay? And you don't need the squiggly mark anymore. You've already done it. So think of it in even basic operations. If I ask you to do 3 plus 2, you get 5. You don't write the plus sign still because you're done doing the plus. It's a way oversimplified example, but it still applies here. Once you've done the antiderivative, you don't need the symbol or the du anymore. Questions? I think we're done. Oh.
I don't get it.
Oh. You get it? Are we okay? Are you sure? All right, hold on. If you answer this question correctly, we'll skip this problem. What would you choose for u? Do you want to get a consensus going, or do you all just want to stare at me like you're scared of me?
I mean, what else?
That's true. Or would it be sine?
I'll take a suggestion for you from each table. Whichever suggestion pops up most frequently, I'll assume that's the answer, and then I'll tell you if you're right or wrong. This table. O is not a choice. 8x.
Will also be 8x.
Peer pressure. It's horrible. That's wrong.
No.
Okay, so I'll show you. Wait, hold on. I'll show you why.
Is it cosine?
Sine 4.
I need to know. Is that cosine of 8x? I need to know.
Hey, we should have taken pictures. We should, yeah.
Is it cosine of 8x?
Sine of 8x, correct. Now notice, I'm erasing. Notice if you take 8x, you just get 1/8 du. Nothing's going to disappear. However, the correct answer is the sine of 8x. One way to realize that is to notice that this is actually that. Okay. And the derivative of sine is cosine, right? So things are going to disappear there. Yeah, it's going to get exciting. Last thing, even and odd functions. We talked about this in the past, but you probably need a refresher. Remember, even functions are functions that are symmetric about the y-axis, and you can tell that by looking at the exponents. If all the exponents are even, the function is even. Why is that significant here? Okay. If I draw you a picture, you'll see why it's significant. Why is the fact that that function is symmetric about the y-axis relevant in an integral? That was weird. Oh, wait, I can fix it.
Oh.
Problem solved. Let me ask my question again.
Something is symmetric to the y-axis, the exponents are
All even.
all even.
Okay, so again, let's go back 2 weeks ago. What is an antiderivative? What does it represent? Area under the curve. So in other words, this problem is saying, what's the area of that and that? So again, why is it relevant?
Oh, because it'll be positive and negative. It'll be the same. So they cancel out, so.
No, don't cancel out.
It's just the same. It's just double.
There you go. This is the same thing as going from 0 to 3 times 2. Now, why do you care? Well, because plugging 0 into an antiderivative is usually a lot easier than plugging in negative 3. If you don't remember that, that's okay. That's the easier one. What is an odd function? Well, the same rules apply. A function is odd if all the exponents are odd. What's the property? It is symmetric about the origin. What that means is that if you take the function, turn it upside down, they're the same. Graphically speaking, we get something like this. Why is that significant? Oh, those are supposed to be 4s. Sorry. Come on, Reedy, read your own problem. What's the answer to that one? Why?
Cancel out.
Yeah, they cancel out. Eh? Remember, anything below the x-axis is negative. So this will simply be 0. The thing I would warn you about is that notice the limits of integration are opposites of each other. If that's, let's say, negative 2 to 4, this doesn't apply. It's got to be from a number and its opposite. Okay. That's just purely a time-saving device. This one, the odd one, I think is more relevant, because what's going to happen is, some of you are going to forget about that. You're going to grind out that integral, get an answer of 0, and be angry. So if you understand the theory a little bit, it'll save yourself a lot of hassles. And the even functions, you still have to just grind it out. But again, sometimes it's easier to plug in 0 than negative 3. This guy, the even or the odd one, can be a huge time-saving device. Okay.
So this only works when the differentials are the same number? Like
Opposites of each other. Yeah. Opposites of each other. What happens if they're the same number? That reminds me of something else. What's this? Why is it 0?
Because there's no area.
Good, there's no area. Okay. Lovely. Questions? Hot diggity. Okay. Hold, please.
Hold it.
Thank you. Let me stop my recording.